Right. So yeah, add uniform buffer member is being called for each member of the uniform buffer. Let me copy this. Struct layout. Template members tuple. Here's something I have to change. I don't know where. Yeah. Okay, so this is passing, or this is specialization of add uniform buffer member for struct layout. And it might not compile, but at the very least I'll add it as a declaration in the class as well. Member index is not a type. Okay, this should not be here. Hello, Jeff. Yeah, it's going okay. I'm trying to add support for structs. So we have a struct layout at some point, just being passed to this function. And that should work. I mean, before I could add a member layout, or okay, I'm totally confused here, I must say. This is a member layout of a basic type layout. This is a member layout of an array layout. So yeah, I should have the same thing here. I think I did it wrong. I need a member layout of a struct layout. Hey written, welcome back. Member layout. So I replace the basic type layout with my struct layout. That thing ends here. And then we continue with member index, etc. So now it kind of works. Just replace basic layout with struct layout, which is a lot less template arguments. I still need a containing clause, I think. See, the basic thing starts with standard, which is that. Then scale index, so that's that. Rows calls alignment, and then array stride, size and array stride. And then we start with member index, which is used here. To missing the containing clause. Error declaration of the is not definition. I don't understand it. This is definitely outside. Huh? I added it to the wrong class? No. Oh, I did not remove the semicolon at the end here. That would not make it a definition, a not definition. Error standard was not declared in this scope. Yeah, that's correct. So we got the declaration correct. Now I have to implement the body of the function, and this should be adding a struct to members. Well, I don't think we have a basic type anymore. We have many basic types possibly, because this is a complete struct with a lot of members. So this seems nonsensical. I do have a full GLSL ID, I suppose. Yes. Maybe some other things from here that I have. Alignment, size, range, yeah. Let's keep it commented out. So members now must be extended with containing a hello harsh and hello Elias. That's the container type of the shader resource member, which is a vector of shader resource member. Which currently can only contain a basic type. Oh. Yeah, we can only have, we are adding members of a struct. And the struct contains, well, these members, for which it says, each member has to be a basic type. And then we have an I just eat breakfast. No. Offset is the offset of this member inside the struct. We can also have arrays of basic types. So then this defines the basic type, and then this defines the size of the array. And this is just a counter for which member it is. Now if we want to store a struct, then of course we still have a member index. And eventually we will add, we'll also keep array size. Hi bear. And Paro, yes, I'm stream every day. Rohit, hi. Offset. So of course we have an offset. Struct has the struct member has an offset inside the struct that we are adding it in. If it is an array of structs, then it has an array size, etc. But the basic type here must now be able to contain a complete struct. Now we saw how that worked, I think. What I'm doing is creating a basic type and then just storing everything in that members vector. So we're going to replace the basic type with whatever information is required to store the whole struct. I'm still going to need an offset. Let's see if we have that. This is my struct layout. It has an offset. Now that will work. And we have a member index, so that will work. And we have a GLSL ID full, so that will work. Yeah, because C++ is fast, I guess. But I don't know. I know that say a company that wants to write programs that deal directly with stock markets, they hire C++ developers because it all comes down to milliseconds or even microseconds. You got to be the first one. Yeah, sorry, I have to continue coding. So instead of basic type, I need to pass something that contains all the information of the struct, which would be the members tuple. Of a copy thereof. Well, that's no fun. I think it takes 3 months of hard work to learn the basics. Yeah, if you have perfect memory and you never get tired and you work the whole day and you have already programming background in a different language, maybe a week is enough. And other people will never learn it. I guess you can make a maybe instantiate the members tuple. I'm not even sure if that's possible. But let's try it. Shall I pass the struct layout? Let's see what information is in that again. So the number of members we have, the layout of the last member, but that's only used to calculate the size. In the end, it's only required to calculate this, all of this. All of it, actually. Well, I have an alignment here, and we have a standard and a size. Yeah, okay. These three are pretty important and interesting. Maybe we should move them. I don't think a standard is really used anywhere else here to calculate. Yeah, see, nothing. And the alignment also not. And the size also not, I guess. So these while underlying class is being used for calculating the GLSL ID. It's more like these lines are needed to calculate the last line. Right. Well, then, depending on if I need it, I might as well store the whole struct layout instead of just the members tuple. Note that the size of a struct layout is 0. It's pure types. This is meta programming. So I'm going to try to simply create an object of this type. Yeah, like this line here. And well, this one is just default constructed. It is empty anyway. So the basic type is not default constructed because it really contains information here. It has a non-zero size. For some reason. That way we do get rid of a lot of template parameters. I mean, in the end I have to store it in this members thing. Which doesn't have any template parameters at all. Just, yeah, this is a real object with bits. It's internal data, internal state. And a basic type we could store in 32 bits. So this size of this thing is 32 bits. But kind of, yeah, we can definitely not store a whole struct in here with the arbitrary number of members and everything. I would have to put all the information of this type into runtime bits, otherwise you cannot store them. Hey return, you mean this? It's called designated initialization. It was something in C++20, I think. So you just type a dot and then the name of the member. They are still in order, but you can skip members. It's just a new kind of notation. And unfortunately, it only works if the object that you are initializing, like this, does not have a constructor. It does not have a base class. It must be a plain old data thing. So I think it's pretty limited. How am I going to store this type information as runtime information in something that, well, when it is runtime, I cannot store arbitrary types, at least not super easy. I guess that in the end I'll just have to store it the way I stored the previous struct, which is as a vector of basic types. I do. I don't know how many subscribers I have. I haven't looked at it for a long time. Just doing my thing. This is. I think this would be a good option to store it. We're going to get types so large that I'm starting to worry if the underlying tools can handle it. I don't know if there's a limit to the demangled or the mangled size of variables and types. Okay, so suppose I already stored here somewhere, somehow. And then also the rest must change. Most notably the accessor here. I now access it as a basic type. But then sometimes I must access it as a, I don't know, struct type. Where is this basic type being called? Blah, 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 blah. So that one, where is it called? That looks like a candidate. This one is just printing it. And here it is used as well, I think. I don't think it's the vertex attribute. It just has a method with the same name. That would be this one. Push constant, same thing. So this is a push constant, and this is oh, there's also vertex attribute stuff. So then, yes, the only place where it is being called is here. That's during the generation of the struct declaration. So here we just write out struct and then open brace, and then for each member we write out the declaration. That's going to be rather easy. The only thing I need to know if it is a recursive struct or if it is a basic type. Well, more than doubled then since the last time I looked. Control T. Okay, now how can I easily detect? I can add a boolean, of course, that says if it is a struct or a basic type. Maybe I can make a basic type that says that it is undefined. I have a standard number of rows and calls, so you could say set the number of rows and calls to 0. I could set everything to 0. Then I don't need a boolean. It's kind of nonsensical in this case, because speed is not that important, and well, I don't know, might as well add a boolean. Does the thing have a default constructor? No, it doesn't have a constructor at all. But I can set everything to 0, and then it would be rather easy. What do we get? Kind would become roses 1, no. Sconces 1, no. Wait, then it would be a matrix with a rows and calls is 0. So I would have to call rows probably. And if rows is 0, then it is nonsensical. Could check the size as well. If the size is 0, array stride is 0. It's all nonsense. Let's do that. So I'm going to add a, let's see, underlying base up the GLS basic type of the variable, or underlying basic type in case of an array, or all nil, all zeros, and this is a struct. And then we add a container type, struct type. The underlying struct type, yeah, when this is, let's use the same phrasing. In case this is a struct or array of structs. Only valid when basic type is all zeros. Right, so normally this is not all zeros, and now I'm adding this one, which is a vector. It just works, I can just insert it. It's just going to add a empty vector, but it doesn't even call malloc. And then I repurpose the whole struct, the meaning thereof. If basic type is all zeros, then this has a meaning, and then it represents the members of a struct. And this is recursive because it is a struct of shader resource members, which is itself. So that recursiveness then ends until we find a vector that only has shader resource members that have non-zero basic types, at which point the container is completely ignored, or when the container is empty, I guess. And it should be either empty or all zeros and non-empty, or empty and not zero, right? I mean, you cannot have both. Maybe add an assert somewhere for that. Yeah. Okay, then I need we can add an assert here. If I call basic type, then it better be not zero. Let's say not is struct. And if I get the container type, which I call struct type, then struct type, then this must be a struct. And then we return that. Well, that's a bit larger than 32 bits, so let's pass that like a const reference. So we have a new accessor for it as well now, and I still need to add the is struct. Just add it to the bottom. is struct blip const return basic type. Well, anything goes. Can I not get the whole thing as an the whole thing is simply 32 bits. Sorry, what happens in the chat? This YMREYY, did he do something wrong? I don't see anymore what he did. I think that's stupid. I cannot even see anymore what. No, whatever. 600 seconds, not that long. Okay, yeah. Ridiculous. Chat, stop floating. I want to continue my code. I guess I should be able to cast it to an uint 32. That seems more clean than just checking one of the values, just rows or just calls. Oops. Let's see if the cast works. Static cast. If it is all zeros, then it is a struct. Now I need to add a constructor. So that's going to be a lot like this one, but different. Begin with duplicating it. Right, so you're passing the GLSL ID string the member index, we do not pass a basic type. Instead, we pass a container type. Maybe a bit simplistic this way. This would take a container type and then add a member where the basic type is default constructed, aka all zeros, and this one then is initialized instead, struct type. And that's a vector, so I use a move. That's a little bit cheaper than making a full copy of the vector. So then we came from here, and then I have to pass a struct type here, or rather move it. And then instead of a basic type, like I did before, we need to create a container type here. So struct type is now a container type. And it is a container type of this shader resource thing. Well, back to members. That's that thing. Let me see what that namespace is. Where it is in. Namespace is shader builder, and we are here in shader builder. Well, shader resource, but still, we are in Vulkan shader builder. So we can just do that, and then the container type has to be public, otherwise, and it is. Otherwise we cannot access it. So this is now a vector of shader resource member. So maybe I should just use that here instead. Standard vector and then that. But well, you know, containers are pretty exchangeable. Maybe at some point I want to change it to a map or a set, and then it's always nice to know where I've been using it. Now I have to fill this thing. I don't take it personally, I think. Or Demir. No, I already had that for a while. Well, Vulkan is the API. The engine is code. Anyway, yeah, now it becomes difficult because you have to fill this container now using the members tuple, if at all possible, as it were. Well, I guess that's much like this. Well, I'm mostly wondering if I should not move this to that class instead of doing it here. Yeah. Okay, yeah, this is difficult. Let me think. How do we do that? I'm going to start with trying to compile this. I think it should compile. I think we also can delete this. It should compile in the current state. And then I want to test my new utility to print the type. Doesn't compile yet. A member function bool vulkan shader builder shader resource is struct const invalid static cost. Okay, so this doesn't work unless I change basic type. I'm not going to do that. Let's just do something silly like rows. Rows is 0, that's good enough for me. No rows is nothing. Last member layout has not been declared. Getting a feeling that I missed something when moving this. Last member layout is used twice. I was mistaken to move this. Okay, I'll move it back. Just last member layout is the only thing we need. I think so. I'm glad I don't have a webcam. Or maybe I should have had a webcam, then I would have put more effort in my, what is that? Persoonlijke verzorging in English. I haven't shaved in a few days and my hair is all greasy. Stuff like that. Well, it did compile or not? It did compile. Okay, that's good. So, blah. Let's make a special function for it, I guess. Yeah, the problem is this has to be done during compile time, right? Because this is just a type, and I want to convert the type into something that is stored in memory, not just in memory, in the heap. Because this is a vector which allocates memory from the heap. And anything on the heap is 100% not going to be compatible with compile time construction. So I need something that generates code without allocating memory, that then during runtime generates my container. And I'm struggling to even make a beginning of how I can approach it. I'll get there, but I have to think a bit. I guess it will come down to calling function, a template function that adds one member and then recursively do that until we added all the members. Constructing it seems not helping. I mean, the only thing I could do for a vector is say constructing it from a begin and an end iterator like this. But that means that I already have it in memory, because then the begin and the end iterator must point to what I want to copy. And the whole problem is to get it in memory in the first place. So I think we'll just start with an empty vector here and then add code below it that fills the vector. And that must be a recursive function. Meta-programming recursive, that is. Pretty dirty anyway. I think it's gonna look a lot like the code that is I have no idea what that is, but I think it has a string in it, first member. So that would be this code. So a lot like this, right? This says make struct layout, and now I want to make the struct type. But we already work with tuples. So I have a layout, make a layout implementation that takes a tuple. Or is that defined? Make layout. Yeah, this is a good bet, I think. So, Control 1. And Control Top. We have here, I think I'm just going to call, it's just fill thing with make struct type. Yeah. Okay, I want to see the tuple first. So this was, I mean, to know a little bit what we are working with. And so this did compile, and recently I added something that is, no, it was a macro. Debug, I guess. Print static. I forgot the name. Of course. Well, we defined it in TWD as debug.h. Debug static print type. Can also not jump to it. Strange. I want to know what this type is. So this is going to work. Ta-da! Our new trick, new utility. Debug static print type. We have a debug. We do not have a debug. It's ridiculous. Of course we have a debug. Something is including debug here. Oh, that's explicitly added. Well, I'm curious if it works. It doesn't. Top position was not declared in this scope. Seems it doesn't work, or at least I'm very surprised that I get this error. Why so little information? Why not saying required from here and stuff like that? Really, really weird. This does not make any sense. I think it's a really bad error, really bad. Let's try clang. Group. Now what? C flags, yeah, well, I need C exact flags. Let's just remove that. Or maybe just use this one. Template backtrace limit, why not? Well, that didn't improve anything. That's really weird. That feels so like compiler bug. I mean, I'm not typing top position. It got it from a type, so it does know what it is. I guess we have to say that my debug static print does not work. We'll have to figure out something else. Damn it. You gotta wonder if that it's not going to give more problems later on. It's passing that type itself here. So why would this not work? I think I get it. It's not a type. I'm not sure. Well, I thought it was a tuple, but and then I've got the output kind of shows that it is not. No, wait, it's actually not true what I said. It complains about not knowing what is top position. Use of undeclared identifier top position. Yeah, it's still problematic. But anyway, V is not a type. So we need to use declaration type, but why on earth can I be complaining? I think this is a compiler bug. I'm going to try and simply include a header of top position, even though that's ridiculous. Yep, I think it works this time. It is very verbose, but in the end, the point is that it's printing the type. Here, T is, so that's the type. Well, that's not a tuple. And it's still not saying where it got expanded from, or which is requiring it. It's also okay. This is a type of this V anyway. So top position dot h. That V here. Now, why do we get an error for V and not for unused one? This is so weird. Okay, I don't know. Let's try to understand it by just using the source code. So the compiler is not really helping. Yeah, I'm gonna need this. Let's open that. So how on earth do we ever get here even? We get here from call to this function, which happens from here. I could use this as well, by the way. That's a runtime thing. Let me try that. It doesn't work. Why is it calling these things twice for each thing? Twice for bottom position, twice for left position, and twice for my uniform buffer. Anyway, the my uniform buffer is the most interesting thing. So let's see what this is. We get here for type, member layout, okay, my uniform buffer, that is the containing class, basic type layout. All right. Yeah, of course, it gets here twice because it has two members. So this is the unused. It's not really printing it, but all these gars here are probably spelling it out. And then the second one is the struct. So this is the information that we were looking for. This is struct layout. So the type of this point is a member layout, and that means it is a member of my uniform buffer. It is the second member of my uniform buffer. And what we're being passed is a struct layout. And the struct layout contains a tuple. And the tuple contains, again, a member layout, and this time the first member of top position, which is a basic type. I'll skip the actual contents here, I guess. Followed by the second member of top position, which is an array layout of a basic type. And that's it. Yeah, well, I think that's exactly what it is, isn't it? So the my uniform buffer begins with a float and then a struct. That's what we saw. And this struct begins with a float and then an array. So we have all the information right there. I kind of need to have everything in my head now, because it's slightly problematic. Okay, both start with a float. And top position is an array of vec3, and this just has a single top position. It's member 2. This tuple, the struct layout contains a tuple of member layout. And I wish I could jump to the corresponding angle brackets. That would be nice. But okay, this is going to end somewhere here, I guess. And then we get another member layout. Right, okay. Let's go back to the code. So that's being printed here. So that's the type of the member layout. Well, I saw only one standard tuple. It should be this one. Not sure how that works, but oh no, this is already an element of the tuple. The whole thing was an element of a tuple. Index, member index, well, whatever. Pretty sure that this is what we print is what we pass. Nope, my memory is failing me. I'll have to make a copy. Let's just create a new console. I'm sorry, but I'm going to use a small font because I need a bit more space here. So let's put this in layer top, so it stays above the other one. And then I'm going to go to the same directory, open top. Then it prints, we get here for type, and that is then the first one. I'm only interested really in the struct layout. So let's delete this line and delete everything to the top. And this on left position, delete everything here. And this is the type, and it is a member layout with the following members. Struct layout, tuple, member layout, top position, basic type. Oh. Yeah, the string literal is very annoying to say the least. What is this? It's 21 characters, 84, 111, 112. I don't know, what is that? It should spell unused. T. Oh, that's going to be top position. So that is TOP. POSI T-I-O-N : 117. That's unused. N-U-S-E-D, and 49 is a 1, right? So let's replace this whole thing with top position : unused 1. On this is then core 15 TOP O, no, top POSION. I'm doing it wrong. It must be here, and : V. Okay, let's make sure 118 is V. Yep. Thus, we can replace all of this with top position V. Well, then this is 77. That's my uniform colon 3 things. Foo. So this is the type. This is the type. And beautiful. I'll put it here. This font is too small anyway, right? So anyone who wants to see it as well? But I'm pretty sure that we're being called with that type on the other end. On the other hand, this is what it is calling, and that says, okay, it's indeed correct. See? So we're calling it with member layout. That's this member layout. Containing class is my uniform buffer, and then a struct layout is a struct layout, and then a members tuple is a tuple. So yes, members tuple is a tuple. And then we get member index is 1, member max alignment 16, offset 16, and the GLSL ID string is my uniform buffer full. It all fits. To the member tuple, members tuple is indeed a standard tuple. I could call add uniform buffer member recursively, if only it wasn't stored in the uniform buffer base. Let me think. Yeah, I think. So these template member functions of uniform buffer base, these three, the only thing they're doing is filling a vector of this type, which is exactly what I now need to do recursively. So I'm trying to think of a API change so that I can reuse it. How can I do that? Maybe I should make this a free function. I can make all three a free function, and then add the M members as an argument. I think that should work. Or shall I not make it a free function? Make it a static function. Yeah, that doesn't seem to make sense. Add uniform buffer member. Yeah, okay. Let's try this. I'm going to make it. Yeah, all three free functions. That's what I'm going to do. So just start with deleting this. And this is simply a members container, which is known by uniform buffer base. But maybe I need to make it public now. Oh, I can just use this. That is public. Anyway, then we get these things. I turn those into free functions. And then, of course, we do not have access anymore to M members. So I'm going to pass member as a reference. Let's just put it as the first one. And yeah, then I need something else. Members. Just gonna use this one. Yes, I'm on Linux. And on here we can just pass M members, because this is a member function of the uniform buffer template class, apparently. Oh boy, this is going to need to sort it as well. Just by memory index, apparently. Rip van Winkel. Yeah. Hi. No. Answer to every question is no. Very easy. No. Yeah. Okay. What am I doing here? We have now three free functions. Should this not still compile now? I guess I could test that. It compiles. This has been commented out for a long time, if you ask me. Apparently I'm using this instead. I don't know, just delete it. Right, so now this can call our free function recursively. Yeah, right, isn't that true? Sort of. Sort of, anyway. Yeah, I'll have to repeat something like this, unfortunately. So, let's do this. We'll create a lambda here that takes a tuple. And then the compiler is going to say, okay, so you want a tuple and it must have these memory layout arguments. And it just reads the types out of the tuple. And then our lambda is a templated lambda with the expanded template parameter pack. And that is a function. A lambda is a function which takes layouts. Within the layouts is then the tuple. Now in this case, so that's as a copy of this, right? So the lambda ends here. And then we call the function by passing this argument to it. The argument is a members tuple which is instantiated, and so I can pass it as and then members tuple is the tuple, of course. Must fit. Yeah, all this is it's kind of funny, isn't it? Nice guy. All this is what are you doing? Well, folding expressions with Ness's lambda. Well, why? I'm drawing a triangle. Definitely funny. Okay, so I need to instantiate my standard tuple and then pass that to this lambda. Let's do that. So this is my function. I'm going to pass something, and what I'm passing is the instantiation of my tuple, which happens to be member tuple. Instantiated. And this function is not doing anything. It's just empty body. But sure as hell, I'm going to check if it compiles first, before we add more complexity. It compiles. We are on the right track. Okay, we copy more. Then the next step is inside that lambda, we create another lambda. As a folding expression. So folding expressions are things that start with parenthesis open, with my cursor's on it. And then you have something. Something is a lambda here, which is also called without an argument. And then after that something, you get a comma and dot dot dot, or the other way around, you get dot 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 comma and then something. And what that is going to do is it's just going to fill that in then. Repeat it. It's going to repeat it. So what this lambda is going to be called several times. Calling it. And it's going to be called for whatever is needed to repeat it. But the dot 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 refers to, well, the same dot 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 as you use here. So for each tuple element, which is we expanded from the tuple, we have a mem layout, and then the mem layout is being used here. And because the mem layout is being used, it's also being used here. Compiler is going to unfold this, as it were, and call this lambda once for every mem layout. So it's kind of a for loop for meta programming of compile time and compile time for loop. And it's C++ 20, right? So you need really a recent standard, C++ standard. So we need to do the exact same above. So the lambda has a capture, by the way. This means we capture everything that we by reference. If we use anything that is not defined inside a lambda. So this reference probably is used for the this. So we have a reference to this. And this is, of course, then just the this pointer of the uniform buffer. And that then in turn allows us to address here m members, which is a member of the class. So if you capture this, then you can use m members. We also capture everything else by reference, which means that I think this is the layout is the only thing that is not defined inside. And member index, for example, is just defined right here. And this is the template parameter that we are unfolding from the pack here. Layouts, however, is not defined inside this lambda. It's a parameter of the outer lambda. So layouts is captured by reference. Well, it was a reference to begin with, so that should be okay. And this is also captured by reference or by value. Not even sure. No, it's this one captures it. I guess maybe I should add here comma this. I'm not sure. I don't think so. I could make it an equal sign. It's kind of silly to capture this as a reference. If you make it an equal sign instead of an ampersand, then it captures everything by copying it. And the only thing inside this lambda here is another lambda. So probably I can make that an equal sign. I don't dare to touch it because, like I said yesterday, this was originally written by Alifa from IRC, which I take in very high regard. And if he uses an ampersand, then I'm going to use an ampersand. So then, understanding that, we can make here a folding expression which contains something, and the something being some kind of lambda, which we call comma dot dot dot. And then that's going to be called for each member tuple. So now I can use member tuple inside this. Let's use the same format here, like that. Now I can use member layout inside here. And that's then going to be called for each of the member layouts. Well, one of what we eventually want to do is fill members, isn't it? Or not? Wait a minute. No. I don't want to do that. I want to fill struct type now. And I want to recursively call add uniform buffer. So we're going to do still very much the same as before. I'm going to guess that we need both lines. Hell, I'm going to copy everything. All of this. So we do have a member layout that we're running over, and now we are also printing the calls that are being done, well, recursively inside here. And, well, why wouldn't it work, right? This is the member index of that layout, and then we just call recursively add uniform buffer members. But this time we don't have an M members. We must add it to struct type, which is the same type. I do have need a layout, but okay, that's just that layouts. So now we can capture layouts by reference. We don't need to capture this anymore, and we're capturing struct type, obviously also by reference. Otherwise, if you make a copy of the vector and then fill it, then we lost it. So both struct type and layouts must be captured by reference. However, I don't think this inner lambda has any clue what struct type is, because we're inside another lambda. But we'll see if it is smart enough. I can imagine it isn't. What what is Moldova? In my youth, I think from 14 or 15 till I was captured by the police, I was a radio pirate. So as an extension of my electronics hobby. So build a transmitter, transmitting on the radio, 105.5 megahertz. I went like, CQ, this is the tornado from, I was living in Eindhoven. So, and I'm a perfectionist to begin with. So, but from that time, I really, I wanted to have the best of everything always. I don't like crappy sound. So then also I've been talking a lot in a microphone. Well, it was also based on it was some not I didn't do things with advertisements or phone games or shit like that. I was just chatting with friends on the using the radio, talking about electronics. Like now I'm talking about programming. But yeah, when I bought a microphone was really for Second Life. To use at some point I got a really serious repetitive stress injury. Both my arms and my neck and my whole back, everything hurt. I could not type anymore. And I was living inside Second Life at that moment. So I had friends, but I couldn't type anymore. So they said, start using voice. So then I bought this microphone. And I just bought a very good microphone. Because that's me. Well, I have the feeling that it should work. Probably not. But this worked. So the memory tuple, we take it apart. And then we get another memory layout stuff-ish, don't we? I have no clue, really. Let's try to compile it. I think it doesn't compile because it doesn't understand what struct type is at the moment, but let's see. Holy moly, it compiles. Well, it's definitely going to crash. Yes. Why is it crashing? Core dump. There's still this problem. We're calling basic type on something that is a struct. I'm not convinced, but let's say it was a good thing that I added those asserts. Otherwise, something else would have happened, and it would have cost a lot longer to find. Yeah, I just want to see what it printed here. calling add uniform buffer members. Let's write the output to my file, my junk file, and then open it. Attention, swap file. Really? It's not this one. What? Oh, this one. I guess just okay. And then write this. I want to keep it. The file's been changed since reading it. Do you really want to write it? Yes. And now we can quit, and then I'll move it to type. Gonna kill this one. Generate that again. Go here. Look for that, and then we have the first call is therefore for the first element of my uniform buffer, which is unused. Then the second call is for the second member of my uniform buffer, which is top position. And that then must recursively call my uniform buffer for the two elements of top position. And that's what it does. Top position. And then the first call is for the float. This is a float, so rows and calls are one. And then the second call is for top position array. Array of size 7 with vec3s. 3 rows, 1 column. Looks perfect. It worked. And now we get the 2 calls to left position and bottom position. So it totally works. And yeah, wow. So let's have a look at the core dump then, because somewhere what was that? Yeah, too late. It scrolled away. I think it scrolled off. Whoops. Okay, we're calling basic type here on member, where a member is member layout of a struct layout. So yeah, definitely struct. Why are we calling that? So that happens here. It should not be doing that. I think we're just always calling basic type somewhere. Oh, this is the this code writes itself, you know. This is the beauty of C++. Almost the whole day, and the only thing I'm doing is fixing compile errors, and then it works afterwards. I love this. I don't know if you were here like 2 days ago. I just made a small change, and then after that I started fixing things. And the end is that we have recursive structs that can contain structs. It's amazing. So this is basically simply telling me that there is still a part of the code that I didn't fix. And that is where we generate the struct. This is generating the declaration. So currently I'm generating this as declaration. And now we have a, well, I'll just type in here by hand what it should become. We should generate struct my uniform buffer float unused one top position which is called v. It's an array? No, it's not an array yet. Okay, I don't know anymore. Tag not found top position. Tag still not found top position. Oh, that's it's not finding it because it's hidden in a macro. Oh. Oh, can't leave the debugger. Already know what it is. Let's go here. So it should declarate the top position. Okay, let's start with the top position then. And the top position currently exists of an unused float. And then a, sorry, that's not true. This one, unused one float. And then a vec3 size 7. With the name V, right? Yep, name is V. Well, this is the correct declaration of top position, and then below that we need to declare a uniform buffer which has a float unused and a top position called foo. Yep. And then it should continue with generating my uniform buffer because that's what I'm using. Something like that. This is what we need to generate. Now I have to say, and I'm starting to doubt that I should use a struct here because you can also put these two inside the uniform thing itself. That might be better, right? I think you can just do that. Why would you do this? Why not just use that? So we do that in one go because I've been thinking about this and I think it's better. So what I really want to generate is this. And I think I can then replace this name with uniform buffer because it must be unique, isn't it? Pretty sure. So I've kind of phased out this my uniform buffer struct. Okay, so if we want to generate this, then we are going to get here for, I think, just for my uniform buffer, not for top position. These members are going to be simply the members of uniform buffer. So I do not want to generate a struct. We're going to have to though, but not right away. The hash we do on the, I don't know. Let's keep this here now for now. Yeah, I want to start with. Wait, I'm just keeping it exactly as it is, and we'll just start over. So do if minus 0. We comment all this out. The minus in front of the 0 is a trick, you know. Otherwise, I don't have highlighting anymore. So this way, it's still commented out, but now I do get my syntax highlighting. So we just start over. I'm writing OSS. And I'm going to start with this. Okay, so we write to the output string stream, simply layout set, then the binding uniform, US, well, the whole thing, B binding, open new line, indentation, not a prefix. Now we want to start with the members, which is exactly what we used to have inside the struct. So let's stop here, no indentation. So now we're going to run over all the members, which means that I need this one. I guess I have uniform buffers. Nope, uniform buffers is defined here. It's a cast of base. Base is defined here. Shader resource declaration. Okay, so in the end I'm gonna need everything. Let's just copy this for now. Let's put it like that. And I'm going to run over all the members. Yeah, and then sometimes it is a basic type and sometimes it isn't. I have the feeling that I should turn this in a function so I can call it recursively, because we are going to need that. If we have structs of structs of structs of structs. Shader resource member. So that was our boolean. First we need to figure out if it is an array or not. If it is not an array, then I can do what I'm doing here, right? If it's not an array, it is a basic type. So I get the basic type and then we print the indentation and convert the basic type to a name. So this is the type of the basic type. Space and then the name of the member. Yeah. And now we can also check if it is an array, and if it is an array, we just add a dimension of that array. And then a semicolon and a new line. And then we repeat. Yeah, this is nonsensical. Sorry guys. Did someone scream? I meant, of course, is struct. I also think we only have to call this once, so I might as well not have the boolean at all. Okay. So now the last one that we printed is this semicolon, and then I want to finish off with that. Which is this part, I guess. Already have a new line. So we just do the OSS print bracket close, and then we have a name, uniform, my uniform buffer, and that is the prefix, I think. Yes, that is a prefix. We're no longer printing a prefix hash, so this can be re-deleted. And let's put a new line after that as well. And a semicolon. Okay, this broke a lot of stuff, but I'm going to compile it, and then if it compiles, I'm going to run it and see what it generated and what we're still missing. Error, assigning to unsigned in 32 from incompatible type char16. There's a quote missing here. Sometimes you get the weirdest errors. Well, that worked. I'm going to run it, I think, and then just see what it generated. So here we have code. Now we should get compiling. There's another code. What? Just search for compiling. Compiling. Yeah, this is what it generated. So that looks good. As intended. We now have not a struct, but I'm just calling this thing by its name directly, and the struct members are inside the layout. That does, however, mean that these replacements are not correct anymore. This is now nonsensical. Let's take this one's easier. That is the left position. So that should become left position dot y, which reads a lot better as well, I have to say. We have to change the code that generated these replacements. And if I remember that correctly, that happens from preprocess which I have called preprocess 1 for some reason. Or not. Oh, it has been split up, yeah. We now have preprocess 1 and preprocess 2. And nobody knows which one I need. This is 1. And this is 2. They are in the same file, so let's just open it. I guess 2. Yeah, here's the code that does find and replace, and it is simply replacing. Well, it's not as simple as before. It used to be name indeed, but a week ago I changed this to substitution. So every time we find a match string, it is replaced with the string returned by substitution, which for a resource variable, and that's what we're talking about, is implemented differently for a uniform buffer and currently returning v prefix hash dot m underscore snake case, etc., etc. And this then has to become, well, we don't do the v anymore, we don't do the prefix hash anymore. We just print a prefix, just a prefix, and then the dot and then the member name. I think this is it. So no prefix hash. I'm missing member name now. What did I delete? Member name? No, it is a function, idiot. What? Then what function is it? Okay, member name was not deleted, so it should still exist. It's probably a member function of a base class or something like that. Still compiling. Let's run this again. Write it to trip. Open the file again. And now we see that it has used my uniform buffer. Oh, that already did. You're looking here it is. So now that does left position dot y. That's correct, and bottom position dot x. That's correct, and my uniform buffer dot foo dot v6 dot z. My uniform buffer, and then foo is there is no foo. But if there was a foo, then there was a top position which has a dot v, and then the rest is correct. So this is already correct, but we still have to generate the top position element. Okay, so that would mean that we have to implement something for when it is a struct. That's here. When this is a struct, then we do you'll have to make a function, so I can call that recursively. It's gonna be some code duplication, but this is writing to, yeah, this whole loop is already. I need a whole loop again. I think that this loop should be part of my function that I can call recursively. Let me think. Annoying. There it is. This is just a members container type, which is the same as we have in it's important is relative, but yeah, I tend to try to concentrate on my code instead of chat. You have to look at it this way. There are 51 people looking. So if I then start to chat with one single person about beginners questions, that has nothing to do with my project. That would not be an, I don't know, honest way to use my time and the time of all the viewers. Plus, of course, I don't have, I just don't personally don't have time to, well, I can answer yes, no questions or something like that, you know, short replies every now and then. If you have a simple question. The problem with reacting to RSL, even reading chat, is that I just get out of it and then I forget what I was doing. It's more time consuming than it might look like. Anyway. I think from this point on, I have a members. I can use this to call a function. So let's insert a function here, and I'm going to call the function generate members. Members. No, not generate. Write members. Write members to OSS. Okay, and then we're going to do this for loop inside that function. That seems super reasonable. And this can be deleted, I think. Copy the most important things. Going to need the snake case or not? Probably not. It would only apply on the prefix. The rest was already copied, so I can just delete this. And then we delete this. And I'm going to make that a function. Then we just put both here. Of course, I forgot the name of the function. What write members to. Standard O stream reference. Yeah, that should be shader resource member container type. Const reference members. Now there is more. Post bunny, yes, I'm single. Is that a proposal? I mean, is that a precursor to something? No. You just probably want to know if it is possible to be a coder and have a relationship at the same time. It is possible if your partner also has a passion for coding and technical stuff. Then you just do everything together and you discuss all the technical things. Okay, this function, let's think about it. Write members to, blah, blah, blah. Called from, there's something missing. What is missing? Why am I saying that something is missing? Well, what is missing, obviously, is standard string declarations. We also pass a string. I could return the declarations maybe. Required declarations. Because it's an output thing. Oh, is this already output thing? I guess it doesn't really matter. Declarations equals write members to doesn't read as well, I think, but why not, you know. Now the declarations must be put in front of the OSS. So if we just break, then we write only OSS, and the OSS kind of expects that that is the case for example, the combined image sampler, which doesn't have any declarations. Well, how shall we do this? I think I'm just going to not break here and just return. And then we return, well, what we return is a string. Declarations. So I return declarations plus the OSS string. So that means that the declaration must end on a new line and even an empty line if I want it to look good, and I do, even though it doesn't matter whatsoever, of course. Okay, so look at the debug output. Okay, so this thing is then returning a string. If the member is a struct, I can get another members thing. Let's call it a struct type from this member. Did I call that also a struct type? Let's have a look. Yep, struct type. So I have a struct type instead of basic type, which returns a const reference to a container type. This is our container type, this is our const reference. The name is obvious. And we're going to need a declaration for that. So declaration is going to be added to something. I guess I'll just use another string stream. An output string stream. OSS. So Sorry, I need a name for that thing. Oh no, I deleted this code, the old code. I think in all cases we just need a prefix. The member. I was looking for my GLSL ID. It is hidden here in the base class. Right, we just have prefix. I think I'm gonna need just a prefix. I'm not sure, but that's either going to work or it isn't. So let's just try it. So the name is probably the prefix of the member. And then let's do a new line. Brace open, and again a new line. We're going to end with close. And this is just a declaration, right? And I want to have a new line after my declarations. And this new declaration must be put in front of the old declarations. But it's empty. Now what if if I'm going to recursively call this, if I had to prepend it, I might as well do it here, right? I mean, if it appended, I could indeed better pass it as a reference and then just append to the string. But since every call has to prepend it, I might as well just return the string and then prepend it. Recursive call is going to happen somewhere here in the middle. That will write to declarations. And then the new declaration, oh, the new declaration must be appended, actually, here. Oh. Okay, so let's append it then. This is writing to OS. I don't even have an OSS anymore. This is now the the OS of the we are passing here. So we're still not writing anything to OS here, but we are adding a declaration, and let's test if that works. I think it's a good thing to compile often in cases like this. You feel a bit unsure. It's easier to see where you made the error if you just added a little bit of code. And when you add a lot of code, and then there's an error, right? Okay, so that kind of worked. This is my uniform buffer, and it added in front of it and that's not good. It should be top position. So we do have the wrong name. And adding a new empty line here is nice, but then there's no empty line here. So maybe should add an empty line after the layout. And then I have too many empty lines there. Or we can put it in front of it. It's just debug output. Doesn't really matter. I think I'm just going to remove the new line for now. Okay, what was next? The prefix is wrong. Member prefix gives me the wrong thing. Why is that? Because I have to loop over damn it, let me think. I'm kind of confused. Why is this write members to? I don't understand why this prefix is my uniform buffer and not top position. It doesn't make any sense. Well, I guess that every member just has uniform buffer, my uniform buffer as prefix, and then the member name is the name. There is no top position inside. It's kind of strange, though. Yeah, I guess we have this. If I want to get the top position as a string, I only can get them with a member of top position. So you just have to start printing the members before I know what the name is of the struct. So the thing that I'm getting is this, because I'm about to run over all the members of it. Feels counterintuitive. You'd think that the member that is a struct should contain the name of the struct, like more accessible. Now this way I cannot generate a declaration of an empty struct. Probably not a problem, but still. That's where you see that there's kind of a problem. Right, but I did it before. So then how did I do that? The code should still be there too, isn't it? Oh, now we know. Now we don't know where it was. I think it was a CXX file. Or not. No, I got lost. Again, this is getting closer. Let's look at the diff of this file. Struct prefix. I'm just writing the prefix. Why? But it's not entirely clear how I got the prefix. Maybe that code is still here. Prefix. Got the prefix from the resource, shader resource declaration object. Mm-hmm. Oh, that is very deep. I don't know where I got that from. What shall I do? Did I just close it? No, let's see. So one way to fix it would be to add a template literal string to struct layout. To get the name of the struct inside struct layout and then pass that along with the standard tuple. Either that or disallow empty structs and just extract it from the first member. To look at the struct layouts are currently being constructed. Yeah. There must be at least one member in a struct layout. Might as well just get it from a member then. And I bet that this is where I already do what I want to do now. Now this is to get the max alignment. Yeah, well. It seems that the struct layout already has its name, although I'm not sure what full means here. Last member GLSL ID SV data underlying class name len. I would think that struct layout has a GLSL ID full, which can only be the prefix of let's say in this case the last member then. I don't know why I'm using it full then, but okay. So why not pass that along with whenever I have a struct layout? Struct layout is being used somewhere else. Where's the struct layout being used? The struct layout is used in here, I think. That seems to be the case. Okay. Add uniform buffer members. This is an element, and then we get shader builder member layout containing class comma, it should have built a struct layout. What? Comma. Okay, so member layout is a member layout. Which has a GLSL ID full. That might be exactly what I want. So the GLSL ID full of a member layout is the GLSL ID str that was passed as the last argument of the member layout. So that will be this one. I'm gonna get a string view of the struct GLSL ID. Maybe do it struct at the end. Is this even used? Oh, it's used here. Members and place back. Yeah, well, I guess so. Well, I'm having the feeling that this thing has something. And this thing is a member layout. I need the X layout, so that would be the layout type. I'm not sure if you can do this, you know that. Well, I'm not sure you can do this. Probably not. No, you cannot do this. So let's use a declaration type, this type. And then we get the layout type of that. And that is then the second template argument of this member layout. In other words, that is a struct layout. And then the struct layout has a GLSL ID full. Pretty sure that now I have a string view of top position here, which then we can start to pass. Let's first check if this compiles. Declaration type member layout, aka member layout, my uniform buffer, shader builder, struct layout, tuples, lots of stuff. Cannot be used prior to colon because it has no members. What the heck? Okay, I think it should compile, but what I'm trying to get is just is this thing, and we have it here, so I might as well do that. Or am I talking nonsense? Well, that was the type that I was trying to get. I want to get the type, this type. But going through the member layout is indeed maybe, well, doesn't make any sense. But I don't think that the compile error made sense either. Moonquake, well, thank you. I've been coding since I was 12, which is 46 years ago, and I have done C++ for the last 28 years. It is still not compiling. Oh, it is compiling. I see this, I think, oh my god, it's compile errors, but it's a tiny little bit stuff here and has fixed it. Now, of course, I have forgotten that what I was doing. What was my last change? What did I want to test? I have no clue. That's the old age for you. And it's worrying me and it's annoying. And then the only thing I can do is just run this again, and then, I don't know, just look at the debug output and stuff like that. I was searching for maybe compiling. That still does not look good. Oh, right. Yeah, but that was the problem. What I was trying was, I was just seeing if this compiled. So now I have the I think a top position name here, and I need to get that inside my call to add uniform buffer member. But yeah, that's not nice because me? No. Well, at some point I said I would do that when I have 10,000 subscribers. But it depends a bit. Depends more on how many active viewers I have. Maybe once a week I could do that once if there's really a lot of people interested in that. I have 1, 2, 3. It seems more better use of my time would be if I would make a YouTube, not a stream, but a YouTube of you know, explaining things. It's a tutorial, but well, you know, so many other people do that. And I have the feeling that most people do it to make money out of it. And I'm not interested in money, so I have little motivation to teach a few people something. Of course, it would reach humanity at large. That would be something interesting. So if I would have knowledge which is important for humanity, and I would, by teaching them, teaching a lot of people, I would leave an inheritance. Then I would be interested in that. But otherwise, my problem in life is that I have the feeling that that I'm not living long enough. I don't have enough time to do what I want to do. What I would like is to have a lot of very experienced people joining my project. So before I die, I can do actually something. Think of Elon Musk. He's pursuing his life dreams with great experts that he gets from all over the world, the smartest people. He must have thousands of them, maybe 10,000s, and they all work for him. So before he dies, he probably sees us land on Mars, maybe even colonize Mars. And he's working on AI now. He wants to have millions of robots in all households. Literally robots. You cannot do that alone. But I'm bad with people. I'm not an entrepreneur. I'm not commercial. I'm a lot of things. Not. I cannot do that. The only thing I do is just I code, and I code alone because nobody's helping me. Well, I don't know. On one hand, I'm kind of like Elon Musk in the sense that I'm also an int-j. If you know what that is. You know this 16 personalities thing? It's kind of a must if you ask me to learn what that is. So int-j stands for... It's one of the 16 personalities. And yeah, if you read this, it's basically about me. Well, not maybe this linear, but the whole description. Architects prefer to make their own discoveries. That's me. Quest to find things, a better way to do things. They aren't afraid to break rules or risk disapproval. I just want to do my own thing and do it better than everyone else, you know, kind of type of thing. And this is also clearly about Elon Musk here. They want to be successful, not just inventive. They bring single-minded drive to their work, applying the full force of their insight, logic and willpower. And heaven help anyone who tries to slow them down by enforcing pointless rules or offering poorly thought-out criticism. Architects don't mind acting alone, so that's what I'm doing. Perhaps because they don't like waiting around for others to catch up with them. They also generally prefer making decisions without asking for anyone else's input. So you are kind of a loner, yeah, lone wolf behavior. But you can do that if you are rich like Elon Musk. I'm pretty sure he believes in what he thinks, and he's probably asking for input when he has to do with a really experienced, super smart guy who is expert in his own field and turns out to be right all the time. And Elon Musk doesn't know it. But loads and loads of people have opinions that are just wrong, and I don't want to have to deal with that. Well, you can read this for yourself. It's on 16personalities.com, and then you write it INTJ, personality. And you can also do a test here. Take the test and find out your own personality. And you will see then the description that you find is going to describe you in very great detail. I really believe in this this site and this test. It's amazing. It's like it's spot on. There are 16 different types of people, and they really know how to describe these people. Well, calling people, I know I'm much older than most of you. So take my advice. This online and probably also in real life, it's always to your own benefit not to say nasty things about other people. So even if he is toxic, it's just better not to say it. I am also trying to read what Lizzie said. I think it's like 2 lines here. You've got to the calibrations, to the instinct of divide. So you have 2 options: either add a calibration chamber or to it, or your second option would be to disintegrate the remaining line of codes. So that's a psychotic remark. There's lots of difficult words in it, but no meaning. I would just leave Lizzie to its weird remarks. I mean, if that's a first remark, then it just comes out of nowhere. I wouldn't call it toxic. Just don't see anything that's toxic about it. It's just nonsense. Anyway. No, I have been very unfriendly. I should not have done that. Okay, the problem is that I have 3 of these things, and only here I can pass the name of the struct that we have, while in the other case we don't have a struct, or I don't know. But okay, it's a string view. Let's just add it. I'm adding it to the end. And now it won't compile anymore because, yeah. Now I have to add string view everywhere, also in this call here. And we have definition 1, definition 2, definition 3. Printing that it is being called. Let me just print. And here it is also called. So now I have to pass a string view here. And that would be then the name of, well, whatever you're trying to get the members of at the moment. Why can I not jump to shader variable layouts? That's strange. Oh, I get it, yeah. I think it's added by a macro as a specialization, so here. So this thing has that as a base class, which has a prefix. That would be a good name, I think. Don't have anything else. Long prefix. Long prefix is fine. Prefix string view. So I could pass the prefix string view that I get from the base class of the shader variable layout thing, layouts thing. Maybe. Maybe. Okay, and then let us not do this nonsense. Sorry, I wanted to pause it here. Yeah, Moonquake. Sorry, I missed it. Thank you and see you. You think this compiles? I think so. Well, after I add string view to these things everywhere. I'm just gonna call this. Now I suddenly have a GLSL ID full here. Of what? Memo layout. Yeah, that's not. Okay, pass the string view, pass by value. I think that's good enough. Not using it here. And this is then the same thing. So an array. String view. And then I already have it, or am I now completely crazy? Yeah, okay, I have no idea anymore. Really, no idea anymore. What's the string that I was looking for? I don't know. This one. There's a 0 here. Something went wrong. also not. Find last of colon. Can we read that column? Yeah. What does substring do here? Yeah, it's very boring. Basic string, substring, pos, count. I have no clue what I was doing here. Oh, it's just a single argument. Nevertheless, it's kind of strange that the 0 is there. It's even stranger that I'm doing this. Well, I'm trying to understand why it printed en passant, well, a null character. And I was printing this thing, so this string view ends up at a null character. Now this string view called long prefix just simply points at long prefix a data. That would be the beginning of this thing, which is an array. To array, this is you have class name, what is whatever, the class name. String eyes puts quotes around it, and then if you just put another string after it, it concatenates it. So this is a string, literal, which ends at a 0 with a certain length and stuff. If we make that an array of that, it certainly has a terminating 0. And if then make a string view of that, then and I use size of the array, then I think I'm getting a string view that includes a terminating 0. This seems wrong in a lot of levels, but I can't wrap my head around it enough to say, well, I'll just rewrite it, because who knows what I'm breaking when I just do that without understanding it. I think there should have been a -1. And even then, the size -4, why? So this is a 0 included. Maybe subtract the 0 and a colon and another colon. Or, okay, so I find the last of it. This whole thing doesn't seem to make sense at all, and I don't know what I'm trying to do. Yeah, I want to rewrite it, but at the very least I have to understand then what the intention was, right? I mean, does this thing have to end on a terminating 0 or doesn't it? I think it should end on a terminating 0, because I might be using it as a character const pointer, so as if it is a string literal somewhere. I think it's scary to change it, so I should change it, but maybe afterwards, you know, after I reach the point again where things work. And I'm also getting very annoyed by the fact that all these static cons expression things cannot be printed during runtime. At least all this is compile time stuff. It's hard to decode, hard to debug that, I mean. Anyway, what I would think that long prefix means that it has 2 colons, and then simply prefix should strip the colons off again. So why the hell would that work like this? Doesn't make any sense. Maybe I think that the problem is probably a class name might contain 2 columns. In that case, I just want the short prefix. So it's trying to strip off any stuff. Let's say if class name exists of foo : bar, then I'm trying to strip off the foo : so we are only left with bar. And that then I'm using as prefix. While the long prefix then is the whole thing. So foo : bar : I think that's the intention. So then the -4 is in order to skip over these colons. And now we do a find of colon to find the colon in the middle. And if we find that, we do a +1, so we start after that colon, and then we get bar : as a result. While if it doesn't have a colon, then we return -1, and we add 1 to that, and then we get 0. So we get the whole thing. I think that's what is intended. Now I understand why it is written like this. And then the template literal is constructed from something so I get the string view, it subtracts 1 from the length. So this n includes the terminating 0. Now if I pass it as data and len, like I'm doing here, then the len must include the terminating 0. And I copy everything except the terminating 0, and then we set the terminating 0. Does it make sense? Say you have a foo 0, then n is 4, so I copy 3. That's just foo. And yeah. So the size indeed should be including the terminating 0. And that means that the long prefix must end on a terminating 0. And it does, because to array. So there's nothing wrong with this code. Mwahaha. Yeah, okay. It was just never intended to use these things. These things are purely intended locally in order to construct this thing. What I should use is prefix and then cast it to a string view if I want it. So this is never intended to be used. I should just use prefix, which I can print anyway. Let's see how that is printed. No, oh no, we're going to 100 billion prefixes. And here, I was working with the prefix. I think it's going to be automatically converted. I mean, why not? Maybe. Because I have to check that. I might not even need this cast. But then again, I added the cast here. I'm going to try to remove this cast simply because I don't understand it. Start it. Valid operands binary expression with the template. Cannot print a template string literal. That's stupid. I did get past this part. It's nice. Let's remove this one as well then. Okay, VT troop. Okay, so that did get rid of the terminating 0, and we have quotes around it. But yeah, I don't think it's called a prefix now because it has, well, it is a prefix. It's not just the name of it. But anyway, let's see what happens. This is being called with this prefix. That is my uniform buffer. This contains the first member of my uniform buffer. And then we call this, which is a struct layout. That is the second member of uniform buffer. And that also passes my uniform buffer. Then we're going to call member layout on top position, the first member of top position, and this passes top position. Oh, no N. Interesting. So both here and there we miss an N. Okay. Why is the N missing? Calling add uniform buffer, and then again, and one of them is it, and I bet it's the new function, which is probably this one. We don't not know for sure, right? So let's add a 1 here in front of it. Let's leave the other one. Okay, it has a 1 in front of it. So when we have a 1 in front of it, we miss a last character. If we don't have a 1 in front of it, we have 2 columns too much. Prefix, postfix of course. suffix. So this is 1 and the other one is newer. Let's call that 2. And this one has a character not enough. We lost a character here. Which probably means that the GLSL ID full simply does not end on a terminating 0. And that is the GLSL ID full of the struct layout. Which is constructed here. Underlying class name len. Yeah, that it cannot end on a terminating 0 because the originating string doesn't have that. Shit. Wouldn't it work if I just do +1 here? Because that constructs a string literal. With an n that is 1 larger. And it's constructing it like this. I pass a data and a len. Len must be equal to the provided argument. Okay, but we're only copying n minus 1 characters and then setting the last one to 0. So although it is yeah, clearly a hack, I could change this and use the fact that it is one or the other. No, not really. Let me just do this then. +1. Hello, cool man. It compiles, and shall we run it again? Yes, we run it again, and now we'll watch it again. And now we have top position and left position. Everything is now correct. The strings are now correct. Poo-poo. Okay, so back to this function. Yeah, this is super confusing still, damn it. It seems that maybe the number 2 is not equal to this one. But then what is it? I want to know. I'll just have to print it. To just print here that number 2, what we're calling it with, is number 2. Hello, Detriné, if I pronounce it in French, probably not. Otherwise it becomes Tetrines. Can't be right. It compiled, we run it, and we look at it, and it prints calling. And then the 2, and the 2 prints now that it is calling it with top position, while number 2 is uniform buffer. Okay. This whole parsing seems to have no sense whatsoever. I don't know why I did it. But at least so I see what it is, and I'm going to need inside uniform buffer. Or, oh my god, what is this, man? It's calling add uniform buffer. Member. Passing top position. We are so not getting this still. The engine is to support me writing something that uses Vulkan. Post Bunny, shut up. You act like you're drunk. I don't like drunk people. Oh ho ho, who said I understood it? Diethic. I'm still fighting this. I'm not understanding it, let's be honest. Calling. So I'm calling this to add a member of top position passing the string top position. But that's not interesting because that's not a struct. The only interesting thing is inside this member function. This is being called with a struct. Then I have my top position name here. Completely lost or Or even my declarations are being added. Seriously. Oh, this is a memo layout. Sorry. Huh? What? No, it's not. Memo layout of struct layout. Right. Well, that didn't work. I'm going to use struct name. So if it is a struct, it must have a struct name. Now you would say that this whole struct name thing is just my GLSL ID full. I'm passing the wrong GL ID full to the constructor of the shader resource member. Nightbot, wake up. Yeah, I'm trying hard. And Post Bunny is still drunk. Well, I'm sure he thought he was very funny, but I think it's kind of distracting for everyone. Let me try to find where this is being used. I guess it's being used during an try and place inside a members thing. Should be able to find that one back. Doubt that it is here. Did I change something here? Struct name, yeah, that still really should be prefix in the end. Was it a girl? Oh well, I thought he or she was drunk, so yes, I kicked it. It's not a random chat box to show off being funny while not being funny, aka being drunk. I cannot not even remember the file names where those things happen. This one, right? And place back is being used. Okay, so I'm having an in place back here of what? Yeah, we lost it completely. No top position or my uniform buffer anymore. What the hell? Okay, I'm not looking at the chat anymore because it's distracting me. What do you think? Um, I need more debug output. Why did the top position completely vanish? I think it's time to take a break. Cannot be productive anymore for this at the moment. I get it. Yeah. That change made it vanish. change that, I guess. Finally. Okay. Getting somewhere now, getting somewhere. I think I should remove all this nonsense that I added first. The nonsense must be removed. This is not a file that I'm looking for. This is not a file you are looking for. Jedi hand gesture. What shall we edit? Probably something like that one. Literally nobody is using this. So let's remove this. Right. What is the name? Oops. Okay, I've give up. Delete everything. Write members to. Oh, I did on instead of to. Okay, this is struct. I'm running to OSS. That is the declaration. We did see that. And we have a struct name. And the reason for that is because I need also to write with indentation that same struct name, followed by space and just a member name, I guess. And then why not again just do this one up after that. Nest pole. I might as well move this outside. Huh? And now we have to write these members of the inside the struct. And finally we can do a trick, a recursive trick. Write to OSS the members of the struct. It's a struct type. Yes, and whatever declarations that come out of that must be prepended to the declarations. Not really prepended. I can do an append, I think. I think also this is just an append then. Guys, it just works. It just works. I have this all the time. Did you notice that? I have no clue what I'm doing. Everything goes wrong. I'm at the verge of just giving up and calling it a day. And then suddenly it works. And then the stream ends and you're left completely unsatisfied because you have no idea what happened. So what I just made working is that we can now have a uniform buffer which contains a struct. And the last thing that I wanted to do was to support arrays. Arrays of structs. Making it worse and worse. Okay. No, this is actually a different array. I already have an array here, so let's give this a hard-coded value, like I don't know, 5. And now it's not compiling. Implicit instantiation of undefined template. Struct member. Okay, I have to support arrays explicitly. It can't be too hard. Yeah, so this one exists, and now I have to extend it with supporting passing an array, which means that we just have a size type added to it, elements. I'm not sure if I used size type before. We have it before there, elements. See, it's kind of the same as here. Concept X layout, and now we are having concept shader variable layouts. And then the thing being passed must be an elements array. And then the layout type becomes something else. So here the layout type is a struct layout. And now I need an array layout. I think I just wrapped that. This becomes an array layout of a struct layout with elements. And with a bit of luck, the rest just works magically. This is then an alignment of the layout of that layout type, which we just changed. And the containing class is still the containing class, I guess. I mean, that's not changed here either. This alignment is a bit different. I'm having an array alignment here. The GLSL ID full is the concatenation of a prefix and a member name. That still looks the same as well. I think the only thing that has to change here is that this becomes the array alignment of the element alignment, I guess. Code editor name, I'm using NeoVim. And if you mean the font and or the colors, you have to ask that, because that's not related to the fact that this is NeoVim. So I need to pass a standard. Well, how do we get a standard here? Standard. Where does someone get a standard from? In the case of a struct member, obtaining class member name, I must get it from the containing class member. Pretty sure of that. In other words, from the layout type. That would be nice. I don't know. Let's have a look. We have a struct layout. If I want to do. And we have an array layout. Let's first look at the array layout. That is directly. It has a standard. Easy. So just the layout type is standard. Right, yeah, I changed foo to an array, right? So a foo was an array, and I forgot what the size was. Not that foo. I'll never know, because I just forgot it. This is also not it. Oh, yeah. See, we can do menus. No, not anymore. I don't know where it came from. Sometimes you can suddenly get a menu. So just prove that NeoVim can do menus with completion stuff and whatever. Just not using it. What I wanted to do was go to top position and then have a look at 5. Okay, so I made an array, top position now an array of 5. No, I don't need an IDE. Plus, this editor could be an IDE if I added the right plugins. As you just saw. Can do menus. I can do a stream once where I try out an IDE and then you'll see that how horrible it goes. Nothing works anymore. Okay, I'm completely lost, of course, where I was. Yeah, here. So foo is an array of 5. Let's pick somewhere in the middle. What about 2? Correct. Can I compile it? I think it compiles. It will not run because I have to change something else as well. It does not compile. No matching function for add uniform buffer member. Okay, that one needs specific, yeah, array support as well. What to do? Let's edit window.h first. And change the GLSL code. So now I have a array of structs, and that struct contains an array of factories. I think that's pretty awesome. But I have to add support to add uniform buffer member, which says it does not exist. Candidate. Let's go to the last candidate. And then extend this one also with an element. Code duplication. Sometimes you just can really not help it. Okay, this is going to look much like the extension that I have above here with elements in it. This one. So we'll highlight elements, gonna be much clearer. So I have to add to the end of the template that size type elements. And that is part of what we pass. Well, I guess so. We are passing an array layout. Oh, right. And then that element must be passed after the last argument of the in-place back. Something like that. Size type elements. And then this is now a okay, I forgot. Let's just scroll up again. Okay, we have a wrapper inside the memo layout after the containing clause of shader builder array layout. And I pass elements to the in-place back. Let's do that first then. Oh, yes, in-place back here. Comma elements. That makes it an array. And then we need this. What is really being passed is not the struct layout anymore, but an array layout of a struct layout with elements in it. And that compiled. How about that? And it works. That was much easier than the other thing. When all the code is there and you wrote it in a flexible way. Right, so now here we see what it generated. Well, of course, the bottom position is still there. And the left position is the same as previous declarations. What I worked on now is the generation of this. So it is generating, just like here, a layout with set to 0, binding 0, blah, blah, blah. And inside this uniform buffer thing, which has the name my uniform buffer, there is a struct, which is also an array. And the struct then automatically gets declared above it. So what I could do is add another struct inside this struct, and then see that that the order of declarations of the struct is correct. Kind of believe it is, but it's not much work, I guess, to test it. So let's just add an unused struct to it. So we'd have to go to top position.h, and then we need a new struct. Do need a new struct, right? So I'm going to make let's call this one some struct. Now what I don't like is that I have to repeat the same standard every time. I'm not sure if I can use different standards. I don't think I can. So they have to be the same. So somewhere I need an assert that checks that. So you cannot make a mistake with it. Okay, so make an some struct here. Doesn't really matter what goes into it. So let's just keep it simple. It's one float. And then we have to also declare it. Declare the sum struct. Which is just a single member. However, I wanted to add this struct to no, I wanted to add it to the top position itself. So I have to define it first. So move it a bit higher. Well, now I'm going to add, I'm just going to add it here, let's say layout, and we add some struct, bar, to top position. Yes, that looks good. This is just the same thing, except we have a 0, 1, 2 in front of it. Undeclared identifier. Oh, I have to declare it first. Let's put this on here. struct some struct. Expected expression. There's no comma. Expected semicolon. No panic, this is completely normal. And then we run it again, and it just simply works still. So let's write this to a file. The debug output it is, and then open that file. And then we see that it generated indeed some struct first. So it declared some struct first, and then it put some struct inside the top position. Recursively. Okay, now I can think of something to make it go wrong. I can also put a sum struct inside my uniform buffer, and I'm pretty sure it's going to declare sum struct twice then. So we need a cache for this. Yeah, it's even going to do that if I add two sum structs in top position. If I add another one, just when it sees this, it's going to generate a declaration, and the next member that uses some struct is going to generate it again. Or, for that matter, if bottom position would use one of these structs, you get the same thing. So I need a global cache per shader of struct declarations. Not going to do that right now because I have my stomach full of it. That would be a Dutch expression. We'll work on that later. It's just boring. It's boring. This stuff is boring. What follows now is boring, but you'll have to do it, I guess. And yeah, most of it just works now. Let's remove this. I don't need that debug output anymore. So we have almost working recursive structs of structs and arrays of structs and whatever. Just implement the cache and I think we are completely there. And then I'm done with uniform buffers. Adding support to it, that is. And then we can go to the next fix me, which is actually last week or so I've been working on this one. It should be multiplied with array size. So I thought, okay, so arrays are not supported. Let's add support for arrays. Now I added support for arrays, and the fix me is still there. So what went wrong? I have to have a look at that point. Why does it say that this must be multiplied with the array size? Yeah, definitely looks like it. If the uniform buffer itself can be indeed an array, but it can no longer. I changed it. The uniform buffer must be a single struct. and then that struct can contain an array. So if you want if you want a uniform buffer just to be an array, then you'll have to make a struct with an array in it and then use that. Which means that I can remove this, fix me, but let's be nice and make it a comment. Yeah, something like that. And I think now we fix the fix me. So I ordered my fix me's by date, and I think it's best to try the last one first. Here's another one that is even newer than the one that I just fixed. Yeah, that's correct. I had a question about this. Is this correct? Setting the offset to the offset of the element X layout type thing. So we have an array layout, and then in order to make it easier to acquire it for certain things, and where certain things means offset, alignment, size, and array stride, you have to wrap it in a layout. So I have I have several layouts. Array layout is just one of them. And if any of those is put inside a layout, you get something that has offset, alignment, size, and array stride. Now the question is it correct that the offset is that thing? And that means then, of course, that we're talking about the offset of array layout. I think it's bullshit. There is no offset here. Offset only have a meaning inside the mem layout. So I would have a mem layout of an array layout. And then we have an offset. So I would think that maybe I added this, not even knowing if it is correct, while it is never being used. And if it is being used, then that is very peculiar. So I'm going to see if it gives me a compiler, if I just comment it out. I'm 50-50 on it. I'm not sure. I feel like it can't be used, but it would mean nothing, right? So indeed, layout should not have an offset. Now, I might have multiple layouts that define offsets, so that would be interesting to begin with, I guess. So this is another one that has an offset. Now it gets scary, because at some point, somewhere I'm going to be using it, no? And I maybe have to add this one back as well, which I never tested. Okay, this is really, I'm not sure about this. Okay, this is the base template The catch-all template, the non-specialized template. That would be the best name, I guess. And then I specialize it for the basic type layout, the member layout, the array layout, and the struct layout. And only the member layout has an offset. So maybe I should just not wrap it in a layout and then try to get the offset. I should just get the offset directly from the member layout. See, that has an offset. So I'm going to remove all the offsets from all the struct layouts and then see where it fails to compile and then just fix that. Which then hopefully was a wrap of a member layout. But okay, I'll be nice and start with a comment. So it's slightly easy to back off when I'm mistaken. That one already had none. Struct layout has one. I must say it is scary. Okay, they're all gone. Let's see whether this breaks. Seems I have been sensible. Assembler, come on. I started with the 8080 or something like that. The Z80 was a little bit later. Offset is no more. Layout offset, that is. So that did fix another fix me, right? Well, this is also in this month. Must be gone. Fix me. This is called once a texture is bound to a descriptor set of the first pipeline that uses it. Shouldn't it be used? What if a texture is used by another pipeline? Well, that's too difficult. Dude, what are you talking about? Yes, I'm Dutch. What shall we do with this? Well, I think I looked at it before and then couldn't get any further than adding that second comment. So how this works is the user defines objects called textures, which stand for a certain texture as being used in shaders. So it's basically a shader input variable that represents a texture. The texture is the texture object is created immediately, but it's not bound to a descriptor set yet. That happens later as a part of building the pipeline or pipelines. So yes, multiple pipelines could use the same texture. They can even use the same shader, or different shaders can use the same texture. Doesn't mean that they use the same descriptor set, but they use then, what does it work? Every time you start drawing, so at the start of every frame, you bind a pipeline, and then you do a draw call, and then you bind the next pipeline, you do a draw call, and so on. And after you bind the pipeline, you also have to bind the descriptor sets that belong to that pipeline. And the descriptor sets have been, that you bind, have been updated with, they call it updated instead of binding, I don't know why. They have been updated with whatever shader resource they're using. So that must be done. So basically I'm creating pipelines plus descriptor sets that I use with those pipelines. And then I bind those descriptor sets to the shader resources, among which could be a texture. And at the moment that is being done then, the updating of that descriptor set that belongs to that pipeline, we are inside pipeline factory that is creating the pipeline. And as soon as the first pipeline binds a random descriptor set to the texture that you said you needed or were going to use, it's calling this override. It's calling this ready function. So this texture is created by the user. Let's say it is an object of your window class. And then someone calls, or a pipeline factory calls ready on it. What do you mean ready? I think it's nonsense, right? The texture should not get a call back at all about being bound or not. Because it might as well been bound to whatever, I don't know. There's nothing we can do, this is just a texture. So I think that the answer is, shouldn't it be used? No. What is if texture is used by another pipeline? Well, whatever, then use it. I don't think we need to know, we do not need to know that it is ready, no. Why have I a ready? Well, the reason that I have a ready is because this texture is derived from base, and base is a shader resource base in the namespace shader resource. And that same base is being used for uniform buffers. So if I do grab project sources for that my uniform buffer, well, base means let's skip a few things. Then I have that defined here, and that is also derived from base, because both a texture and a uniform buffer are in fact shader resources. And why do I need to know that the uniform buffer is ready? Because I can only start writing data to it at the moment that it is created. But that's where I say something. Suppose the uniform buffer has been not created yet, so there is no memory to write to, then I cannot write to it. So we have to wait until the ready is being called, and then we can start writing to it. But if it is created but not bound yet, not by one pipeline, not by two pipelines, not by, I don't care how many pipelines is using this, this is the same story as texture. I just don't care. I can start writing to it as soon as it is created. And in the beginning, when I started to design this, there was not really any difference between creation and binding. I just created it and binded it all in one go. And in the meantime, that got like split up 8 times or something, or well, 3 times, and so in 8 pieces. and it got completely ripped off each other. The creation and the binding now have little to do with each other anymore. I think that what I need to know is whether or not it is created, and not at all whether or not it is bound to a descriptor set. Let's see what this base all thinks about that. Set created. I have a set created and an is created. And that should be sufficient. The ready is like, well, okay, I split it up, so I still have to know when it is bound. But I don't think I ever need it. So I'm going to delete the ready. We do not have a ready anymore. We don't need it. I can use is created. And as soon as is created is set, I can start using it, even though no pipeline is using it. That's kind of a question if is set created is ever called for a texture. I have to check that. But okay. Now this gives a lot of compile errors, but let's be nice and just find them where it is being used. So just ready, right? Not is ready. So there's no virtual function anymore, therefore we cannot override it, and therefore we don't have this, and we don't have this, and we don't have this, and basically we don't have a uniform buffer slider. Okay, we don't have a uniform buffer slider, whatever. See the resource uniform buffer. Yeah, let's delete all of it. So let's do undo. This whole file can be deleted. Get remove. And then I grab wherever it is included, because the file doesn't exist anymore, therefore we can no longer include it. That is in window.h. So we don't include it anymore. But that means I can no longer use it. So let's see where it is being used. It's being used here to what you don't have a sliders anymore. So delete this part. And then it probably doesn't know where the uniform buffer can be found, but that was in the same place as the textures. So I just add the namespace in front of it again. See, that's what I mean. This is the user code. Window.h is the user code. So they just say I have a texture and I have a few uniform buffers. And here you see that our structs, you know, that we're using. And well, we don't have the is ready anymore, so instead of is ready we're using now is created. You see, as soon as they are created, then we start writing to it. And yeah, now we do that before they are even bound. Hopefully that works, but I think so. Did I forget something? I've got the other one from the texture. And that removes this fix me. That is, if it works. Let's hope so. I should have committed first, of course, before I started making all these other changes. Yeah, of course, I'm still calling ready, but it's no longer necessary. This can all be deleted. We're not interested. That was at the end of wherever I'm updating my descriptor sets. UBT, it still works good. That one also still works. There's a fix me here. A little fix me. Yeah, definitely have to fix that. But before I do that, I'm going to commit it, and I'm maybe not even going to commit it until, well, not now. I think I have to go eat. So I'm going to make dinner and then eat and then do other stuff. And then I'll be back. Probably this evening. It's the end of the day, but when I get ontwenningsverschijnselen after a few hours. I don't know, what the hell is that in English? Last thing I want to do is break my own code so that I am forced between quotes to fix that cache problem. And that means that I just have to split off my, well, we don't need any fancy stuff, so I'm just going to split off some struct, I think. And let's edit this, some struct.h. You got to break it before you can build back better. Everything has to go. Leave nothing alive. Where is it? This thing goes like delete, next, paste. Now we're gonna need the same headers. The same headers, so now it's split it up, right? I split it up, right? Yes, thank you very much. And then we do and include some struct.h here. Yeah, we need a great reset. We need to break everything. The whole monetary system must go down. Let's crash everything. No food, no energy, no freedom. The only way to go. Because we have to save the environment. Well, not really. Okay, let's do blah blah blah. We have some struct now, and I'm going to add it as well to, let's say, left position.h. called like that, some struct. You made political remarks. I am not going to be mad about anything you say about politics, trust me. I believe in open discussions and stuff like that, and not in censoring. The fact that currently, or certainly in the last years, it starts to be a bit relaxed, more relaxed, but has been crazy that you were literally not allowed to talk about certain topics on the internet. You could not give your opinion, not even if you were a professor, an expert in the field. I mean, fuck that. I'm not going to play along. Some struct, let's call this unused 2. People have completely lost their minds. I miss something here. There must be a layout still. Talking about missing, this is not the way to do it these days. Okay, so we have some struct here. Unused 2. And this is called, should be called, struct declaration, left position. And this is then member 0 mod 4 comma unused, and member 1 some structs comma unused, and member 2 left position, and we have bottom position. Don't get excited, post bunny. Struct declaration. Member 0 is what was it? A float. And the member 1 is also a float. It's amazing, isn't it? All the float are floating around. Nobody has been alerting me. I just saw it myself. Fact 2. Let's hope this compiles. Yeah, exactly. I've been part of certain groups as well to, you know, keep at least to try to keep up to date with what really was happening in the world. And those same places were full with complete idiots screaming that Bill Gates wants to kill half of the population, like literally, that the vaccination would deliberately decimate human population. Loads of people on both sides lost all touch with reality. But yeah. What to do next is run it again, I guess, and then see that it crashes, because redefinition of some struct as predicted. ubt trup less than minus r trup, and then we can look again for compiling, and then we see that indeed it generated some struct here because it's used in top position, and then we have my uniform buffer, and then it tries to declare some struct again because I'm using it here in left position. So yeah, do I have to fix this? So now I broke it, and then I can fix it again. So they are right. And now I'm going to off stream because I'm going to make dinner and eat. Tomov, my brother. I didn't know you were on YouTube as well. What's with the nickname, brother? My brother would never be on YouTube. I think you're a fraud. Okay, I was just kidding, right? You understand that? Don't take me seriously. I'm looking for OBS to stop the stream. I found OBS. I'll be back later. Thank you very much, all the C++ coders.